Hi, this is Deepa. Today I am going to tell you how to get started with ISE Design Suite 14.7. This is the icon. Click on the icon. A window appears like this. Click OK. If any project is open, go to File, Close Project, File, New Project. So here I have already created a folder with the name dd_lab in F drive. Similarly, you can also create your own folder and give a name here. I am writing the VHDL code for 2 input AND gate. So I am giving the name as A and 2. Top level source type should be HDL. Click on Next. Evaluation board type is non-specified. Product category is all. Family is Spartan 3. Device is XC3S50. Package is PQ208. Speed is -4. Synthesis tool is XST. Simulator is iSim, which is from Xilinx. Preferred language is VHDL. And VHDL source analysis standard is VHDL 93. Click on Next. This just gives the project summary. Click Finish. Now a project with name A and 2 is created. Now we have to write a source file. For that, go to Project, click on New Source, click on VHDL model, give the name as A and 2. Add to project should be ticked. Click on Next. I'll specify the inputs as A and B. So A, B. Output is C. Set the direction as out. Click on Next. So this is pin description. Finish. Now a project with the name and2 is created with the source file as and2. And this is the source file. Entity and architecture are already written. Write the logic after the begin. C is equal to A and B. Click on Save. So it is showing completed successfully. That means there are no errors. So we can go for synthesizing the design. Click on Synthesis XST. So once synthesis is completed, we can go for writing the test bench for 2 input AND gate. And once the green tick appears, it means that synthesis is done successfully. Now go to simulation. From project also we can add a new source file, or from right clicking on the device we can add a new source file. Click on VHDL test bench. As we are writing a test bench now, it is and2_tb. Always remember that test bench name should be different from the source file name. Add to project should be ticked. Click on Next, Next, Next. So now a test bench source file will be created, and this is the test bench source file. As we are writing the test bench for 2 input AND gate, we do not need any clock, so I am commenting this one. Here also it is about the clock description, so we will comment this one. Here also we do not need any clock description. Here we will give the 4 input combinations for the AND gate. Now I am giving the first combination as 0, 0. Next combination will be given as 0, 1, and other combination will be given as 1, 0 and 1, 1. So it is 0, 1, 1, 0, 1 and 1. Click on Save, and it is showing that completed successfully. Click on Test Bench, go to iSim Simulator, behavioral check syntax. So it will be checking the syntax of the test bench. It's okay now. We can go for simulating the behavioral model. This will direct us to the waveform window where we can functionally check the truth table of the two input AND gate. Click on zoom view. Here we can see that when both the inputs are 0, 0, output is 0. When 0, 1, output is 0. 1, 0, output is 0. When both the inputs are high, output is high. So this is satisfying the truth table of the AND gate. So next we can go for implementation. For that, first we have to write the user constraint file. Go to user constraint file, IO, planning, plan ahead, post synthesis, click on S. This will direct us to the plan ahead. Once plan ahead is open, we can map the input outputs of the design to the input outputs of the FPGA. In FPGA, toggle switches are the inputs and LEDs are the outputs. So now the window is open. This window gives the description of the plan ahead. So once this is done, we can map the pins. Along with the FPGA kit, pin description sheet will be given. By looking at the pin description sheet, we can allot the pin numbers to the inputs and outputs of the design. So click here on the plus mark of the scalar ports. A and B are inputs, C is the output. Go to site. So pin number 21 is the first toggle switch. Pin number 27 is the second toggle switch. And first output LED is P20. Save it. So now it is saving the design. Once it is done, minimize this one. Now we can go for the implementation of the design. Click on the implementation. Clean implementation of the design goes through translate, map, place and route. So translate and map are ticked now. Waiting for place and route. Once all are okay, we can go for generating a programming file. Generating a programming file will give a .bit file which will be dumped on the FPGA kit. Now AND2 .bit file will be generated. Go for configuring the target device. Click OK. Now impact window is open. Click on boundary scan. Right click, initialize the chain. Here we can see that XylinxF02S is selected, which is not our target device. XY3S50 is our target device where we have to dump our program. So bypass the device. Cursor will come here. Now we have to select AND2.bit file. Select this one. Click on open. Select the device FPGA XY3S50. Click on FPGA device specific programming properties. Click on OK. Now click on the XY3S50 device, right click and click on the program. Now the program will be dumped on the FPGA kit. Through the video I will show you how FPGA kit is connected to the power supply and JTAG port, and after dumping how the FPGA configured to work as a AND gate, and this is the FPGA kit. This is the power supply of 5 volts. A 5-volt power supply is given to the FPGA. This is the connection for the JTAG. And from JTAG it is connected to XC3S50. These are the toggle switches which are used for giving the inputs, and green ones are the input LEDs and red ones are the output LEDs. Now as the programming file is dumped, we get to see when 0 0 output is 0, when 0 1 output is 0, when 1 0 output is 0, when both the inputs are high output is high. This is how programming on the Xilinx 14.7 is done. Thank you.